All right, good evening, and thank you everyone for joining us. My name is Adrienne Underwood, and I'm the Communications Director for PSE Healthy Energy. We're a nonprofit research institute based out of Oakland, California. And today we'll be sharing the findings of a new report on air quality in Richmond, North Richmond, and San Pablo neighborhoods located in Northern California's East Bay. So my colleague Jacqueline just dropped the link to the study website in the chat. And so you can access the study and today's presentation on our website. This webinar is being recorded and a video will be available on PSE's website and YouTube tomorrow after the presentation. If you have any questions during the presentation, please drop them in the Q&A at the bottom of your screen and our panelists will respond after the presentation. So with that, I'm gonna, Karan, can I have you present this next slide? Thank you. Great. Okay, so with that, I'm going to introduce our panelists for today. First, we'll hear from Dr. Boris Lukanov, a senior scientist at PSE Healthy Energy, whose work focuses on clean energy and equity and air quality. Next, Karan Shetty, who is a clean energy transition analyst at PSE. We'll discuss his work in this study. Karan's work focuses on both data analysis and science communications. And finally, we'll hear from Rebecca Shurgru, sorry, Rebecca, a member of UC Berkeley, who joined PSE's Richmond Air Monitoring Network as a collaborator in 2020. Her research focuses on understanding mobile sources of air pollution, particularly environmental justice communities in California. So with that, I will hand it over to Boris.
Thanks, Adrienne. I actually am having trouble seeing the slides. I don't see the slides. I don't know if anyone else is having the same issue.
Having the same issue. Okay,
let me request control. See if they appear.
Sorry about that.
I still don't see them.
Okay, let me stop the share. Give me 1 minute.
There it is.
Great, sorry about that. Okay. Our panelists, and I will hand it over to Boris.
Okay, thank you, Adrienne. I'll start, let me actually move to, okay, let me see if I can control the slides. I'm actually having trouble controlling the slides though, so here we go. That was a little slow. Okay, thanks, Adrienne. I'll start our presentation with the why we decided to take this multi-year journey to measure air quality specifically in the Richmond area. And also with the what exactly we did and how we did it. And then we'll talk about our findings. And at the end, we'll discuss potential mitigation strategies. Ooh, again, I'm having, okay, here we go. The Richmond-San Pablo community is home to what I call a bouquet of industrial polluters. As seen on the left here, these include the third largest refinery in California, a port with a coal terminal, chemical facilities, landfill, warehouses, manufacturing. The list goes on and on. The snapshot on the left here is part of an interactive tool that we developed early in the project to visualize estimated annual emissions from all permitted facilities in the region. These facilities report to the California Air Resources Board, and their estimated emissions are shown here in tons per year for several air pollutants. And we can provide a link to this interactive data tool at the end of the presentation or now, so you can explore the data on your own later. In addition to these many and large stationary sources of air pollution, traffic is also a huge contributor to local emissions. The community is intersected by 3 major freeways, I-580 to the south, I-80 to the east, and the Richmond Parkway to the west, which connects the 2 interstates. So every day, tens of thousands of cars and trucks commute along these freeways, not to mention daily traffic on city roadways, as well as industrial trucking activities. On the right here, we show our estimates for annual on-road emissions of fine particulates in tons per mile traveled. But there are also mobile emissions that are not included here, including road dust, coal trains, cargo ships, etc. So to sum up, the area faces sort of a perfect storm of emission sources. In addition to the many local emission sources, wind patterns also play a role in how air pollutants are transported across the area. Generally speaking, winds in Richmond come from the south and the southwest. This means that air pollutants coming from the industrial areas to the south and southwest can be blown north across Richmond and San Pablo. On the left side here, we show hourly wind data compiled from several wind monitors by the Air District. On the right-hand side are data that we collected from several weather underground stations. And they also show some seasonal variations in wind patterns. This slide is showing health outcomes for the Richmond area by mapping 2 very important health indicators. One is prevalence of asthma, shown on the left-hand side, and the other is prevalence of low birth weights, shown on the right-hand side. Each of these health indicators can be related to poor air quality. These 2 indicators are part of CalEnviroScreen. For those of you who are not familiar with it, CalEnviroScreen is California's geospatial tool that integrates various environmental burden, health, and socioeconomic indicators to identify environmental justice communities in the state. The map of asthma rates on the left-hand side shows that Richmond and San Pablo experience some of the highest rates of asthma in California. This is indicated by the darker green color on the map. Similarly, census tracts in the Iron Triangle, North Richmond, Hilltop, the Richmond Annex, are also among the top 25% in the state for low birth weights. This is shown here on the right-hand side in the darker brown color. And the story is similar for cardiovascular disease, which is another health indicator that can be related to poor air quality. I'm having trouble switching. Here we go. At the same time, there seems to be a strong disconnect between these poor health outcomes observed in the region and air quality data that has been available for the area up to now. CalEnviroScreen indicators for fine particulates, for example, shown on the left side here, and ozone, which we're not showing, both indicate that area-wide concentrations are pretty low, below the state median, and they're fairly homogeneous. So if we look at the map on the left, the takeaway is that there is no real air pollution problem in Richmond when it comes to fine particulates. One reason for this disconnect between health outcomes and air pollution data is that there is only one long-term regulatory air monitoring station in the area, which measures important criteria pollutants such as fine particulates, ozone, nitrogen oxides, all of which are known to impact public health. The lack of more granular data on the ground and at the community level means that localized air pollution hotspots are frequently missed, and actual exposures on the ground are just not known. And there is no monitoring at all for black carbon, which is the main component of diesel particulates. So the diesel particulates indicator in CalEnviroScreen, shown here on the right-hand side, is based only on estimated on-road and off-road emissions rather than air monitoring. So again, actual levels on the ground are just not well known. Another reason for why we see a disconnect between health outcomes and available air pollution data is that air pollution is only one piece of a much larger puzzle. In the broader context of cumulative burdens, many factors, including, but not limited to air pollution, of course, can contribute to poor health outcomes. These factors include socioeconomic burdens, a lack of access to healthcare, poor housing conditions, demographics, other environmental burdens, etc. These cumulative factors are included in the total colon virus screen score shown here on the left, and also in the total population score shown on the right, which is a combined score of community characteristics that can result in increased vulnerability to air pollution. What we see is that many census tracts in Richmond and San Pablo are in the top 25% of California census tracts in terms of these cumulative burdens, and therefore are designated as environmental justice communities in California. So this is certainly another very important factor. But regardless of these cumulative burdens and population vulnerabilities, we still know that there is significant lack of data on what air pollution levels and exposures are at the community level. So we wanted to try to address this issue by deploying a dense network of air monitors in the area. Here we go. So with all that information discussed so far in mind, and with financial support from California Air Resources Board through the Community Air Grants Program, we started deploying the Richmond Air Monitoring Network in early 2020. We deployed 50 air monitors throughout the area and collected data continuously for 2 years, with each monitor collecting measurements every minute of the day. So that's 50 air monitors times several air pollutants, over 1 million minutes in 2 years. So that's hundreds of millions of data points altogether. 29 of the 50 air monitors were located in residential areas, 14 were in commercially zoned areas, 7 were in industrial areas. And of course, community members live in all of these zoning categories. I should mention that 31 of our air monitors were hosted by community volunteers, which we are very grateful for. 15 were hosted by local schools, 5 were at local businesses and a fire station, and 2 were co-located at the Air District's regulatory site in San Pablo to help us with quality checks. The regulatory site is marked here with a black diamond on the map. Sorry, I think it takes some time to switch to the next slide. Okay. So we chose to monitor for fine particulate matter, or PM 2.5, nitrogen dioxide, ozone, and black carbon. We decided to monitor for these 4 air pollutants for several reasons. One is that these air pollutants are known to cause respiratory, cardiovascular, and neurological diseases, especially in vulnerable populations such as the children and the elderly. 2 is the abundance of local emission sources of these pollutants, as we already discussed. And of course, the lack of air monitoring data for these air pollutants at the community level. So as I mentioned earlier, there's just one regulatory air monitoring station in the area that monitors for for PM, ozone, and nitrogen dioxide, and there are none for black carbon. And the last reason is that reliable and accurate local sensors have become widely available for these 4 air pollutants over the past few years, which is what allowed us to deploy a large and dense network of air monitors to cover the entire community. I should also note here that the path of these air pollutants from their emission sources to impacted communities is actually quite complex. Pollutants undergo various chemical transformations in the atmosphere. Some form secondary air pollutants, some react to sunlight, and all are impacted by weather and wind patterns until they finally reach the places where people live and where their impacts are felt, which could be a distance away from the original emission sources. And that's why it is so important not to rely only on emissions source estimates and modeling, but to also make measurements on the ground and in the communities where people live, work, and play. Broadly here, the high-level objectives of our project included first, data collection for multiple air pollutants. As I said, PM, ozone, and nitrogen dioxide, because these pollutants are strongly correlated with adverse health impacts, and because of the high-quality local sensors that are now available for these pollutants. And black carbon was also added for the same reasons in collaboration with the UC Berkeley team. The second goal was to conduct high-density monitoring with data collected every minute, with the goal to map local concentrations, detect short-lived pollution episodes, identify local air pollution hotspots, etc. Our third goal was to visualize the data in real time. We did that in a way that was publicly accessible, and we collaborated with another air quality data collection effort in the area that was done by ACLIMA. Our fourth objective was community engagement. Working with APEN, we aim to raise awareness, provide reliable data to address local air quality issues, and also encourage community participation in both monitor site selection and deployment. And finally, policy engagement. Our goal was to provide reliable, hyperlocal air quality data to the community and to regulators, and ideally translate that data into insights that can support decision-making at the local, regional, and state levels. Okay, so without further ado, we'll transition to some of our key findings. I'll present a couple of slides, and then we'll pass the baton over to our colleague from UC Berkeley, Rebecca, and my colleague at PSE, Karan, who will discuss the rest of our findings and potential mitigation strategies. Okay, so our first key finding is that traffic is an important source of PM, nitrogen oxide, and dioxide and black carbon pollution in the region. In particular, we know from vehicle emission factors that heavy-duty diesel trucks contribute a disproportionately high amount of these pollutants, despite being a minority of on-road vehicles. As we'll see in the next few slides, we found that PM, nitrogen dioxide, and black carbon were elevated during commute hours, near freeways, such as I-80 and 580, and during times that could be associated with industrial truck activities. Further supporting connection to traffic, we also observed nitrogen dioxide concentrations that were highest within half a mile of major freeways, and they dropped significantly beyond that distance. Our next finding was that average PM levels varied quite significantly throughout the area. This is in contrast to modeled concentrations that I showed you earlier with the column virus screen PM indicator. So that was based only on sparse regulatory air monitoring. The map on the right-hand side here shows average measured PM concentrations by neighborhood as a % difference from the measurements taken at the San Pablo regulatory site. And as you can see, average PM levels were highest in southern neighborhoods near Point Richmond and the Richmond Annex, and also in northern neighborhoods such as Hilltop and May Valley. Average PM concentrations there were roughly 20% higher compared to concentrations measured at the regulatory site in San Pablo. Neighborhoods in the north may be more impacted by secondary PM formation, as they're further downwind from the main emission sources of primary air pollutants to the south. Neighborhoods in the south are also close to 580 and all the industrial areas around it. PM levels were particularly high in the summer and fall months. This is due to wildfire smoke mostly, but they were also high in the winter months when wind speeds were low and pollutants often get trapped under a low atmospheric boundary layer during that season. And now I'll pass this over to Rebecca to present a couple of slides on the black carbon data that her team collected.
Thank you. I'm just going to get access. And just waiting for the slide to change. Think it's happening. Or if Adrian, if you just want to go ahead and change the slide. That works for me too. All right. Well, thank you, Boris, for the introduction, and Adrian as well for the help with the slides and introduction. So in addition to the spatial patterns that we're seeing with the fine particulate matter, our additional measurements to study black carbon, or what's commonly referred to as soot, it better indicated local pollution sources that were in the Richmond-San Pablo area. So on this map that I'm showing here, I'm showing each of the sites that we had a black carbon monitor at, and it's being colored by what we're calling a normalized black carbon concentration, where a normalized value here is the average black carbon seen at a site divided by the average black carbon seen across the entire network or entire community. So in that case, the sites colored in red are experiencing higher pollution than the network average black carbon levels. And what we see is that those red sites tend to be clustered in this southern and western area of Richmond and San Pablo, following along known sources like I-580 and the Richmond Parkway, as well as the railway that exists there. Typically, these sites land in what were zoned as industrial sites, keeping in mind that both homes and schools still exist in those areas. Moving on to the next slide. Yeah, in addition to the spatial patterns, the combination of the 3 different pollutants that we measured, specifically black carbon, NO2, and PM 2.5, were really helpful in identifying potential local sources when looking at the temporal patterns of these pollutants. So here I'm showing the typical diurnal pattern that was measured during January and February, or what we call the winter time, typical winter time in the area. And as many of you know, and what we discussed earlier from Boris is that the diurnal patterns are driven by not only the local emissions in an area, but also the meteorology or local weather patterns. So what we're seeing in this as an example, and what we know already with diesel trucks being a large contributor to black carbon and NO2, we see a rise in both of those pollutants in the morning time, which corresponds to the known rise in diesel traffic during that time. In the evening, the wintertime evening peaks in black carbon are as pronounced as the peak in the morning, whereas the peaks in the evening NO2 and PM 2.5 are less evident. And this potentially points to additional yet different local sources of pollution, such as residential wood burning that would occur during wintertime evenings and enhance those black carbon levels additionally. And then I will pass it back to Karan, I believe.
Awesome. Thanks, Boris and Rebecca. So jumping quickly back over into the spatial trends, we saw that average nitrogen dioxide or NO2 levels were highest near major freeways and expressways, kind of tying into the points that Boris and Rebecca talked about earlier. And this is to be expected as NO2 is associated primarily with emissions from car and truck tailpipes. We saw that average NO2 levels were highest in neighborhoods that are adjacent to I-580 and I-80 and the Richmond Parkway. So for instance, Marina Bay, Point Richmond, North Richmond as examples. Next slide. Another finding is that we found this, it's very advantageous to have a dense sensor network because we're able to use it to identify fast moving pollutant plumes and identify acute exposure events that move through a region. Now, these exposure events don't last very long, sometimes less than an hour, but plume concentrations spike during these times, which has potential adverse consequences for health. So in this video that just played really fast, and we can play it again, this is a plume that occurred on November 3rd, 2020 between 5 a.m. and 11 a.m. And you can see in the red for PM 2.5, these concentrations start rising in the Northeast and the hills before this plume kind of quickly moves through the entire city in the span of about an hour before it kind of recedes back again by 11 a.m., like late morning. Why this happened, there was a reported Chevron refinery flaring event on this day. The stacks at the refinery are pretty high, so it is possible that some of those emissions kind of were emitted and went over the city and kind of settled down in the hills due to wind patterns before kind of moving to the area. However, there are other possible explanations as well. November 2020 is still during that like bad wildfire season we had in the Bay Area. But the key point here is that this dense sensor network picked up plumes like this, and we had many other plumes that we identified that moved to the area, and can be useful for discussing mitigation and community health. Next slide. And tying into that point, we saw that wildfires were the cause of acute PM 2.5 exposure events. This graph here shows that really bad wildfire smoke season we had in the late summer of 2020 between August and October, when we had those orange skies. The air quality was really bad due to wildfire smoke in the Bay Area throughout the East Bay. And we see that during this time period, PM 2.5 concentrations measured by both the regulatory site, shown in the black line, and our sensor network, shown in the orange line, far exceeded the federal 24-hour PM 2.5 standard of 35 micrograms per meters cubed. In some instances, PM 2.5 levels shot above 200 micrograms per meters cubed. And you can see with the black dots and the blue dots at the bottom there of the graph indicating wildfire events and wildfire smoke events. So these acute exposures, again, they don't last a long time. However, these PM 2.5 levels are very high. So this implies adverse health outcomes during these times. Slide. And finally, putting all this into the context of public health, average PM 2.5 concentrations over the 2-year study period exceeded health-based standards. So for the full study period, our network detected average PM 2.5 levels around 12.6 micrograms per cubic meter. This is including wildfire events. This is around or slightly exceeding the federal standard of 12 micrograms per cubic meter. However, I'd like to clarify, this is not an apples to apples comparison. However, we use this federal standard of 12 micrograms per cubic meter just as a reference point and a baseline for comparison. However, the World Health Organization has an annual standard of 5 micrograms per cubic meter for PM 2.5. And for 2021, the PM 2.5 average is around 10 micrograms per cubic meter, double this WHO annual standard. And again, this likely has consequences for adverse health outcomes. For NO2 and ozone, measurements were lower than federal standards. However, adverse health impacts are still possible at these lower levels. So based on these key findings, we have some mitigation strategies and recommendations moving forward. Slide. First and foremost, heavy-duty truck electrification, public transit, and other traffic emissions reductions should be prioritized. We saw, thanks to Boris and Rebecca, that it seems that diesel engines and these heavy diesel trucks are primary sources of particulate matter and NO2 emissions in the area. So providing businesses with the incentives to electrify their truck fleets and moving up the timeline for 100% zero emission medium and heavy duty truck sales should be prioritized to protect communities from industrial truck pollution or heavy truck pollution. We should consider rerouting trucks away from areas experiencing high cumulative environmental burdens. And as we should also look into investments in local and regional electrified public transit to reduce the sheer volume of vehicles on these major byways, especially I-580 and I-80. A measure or a suggestion that was very popular in some of these community CERT meetings was tree planting and other urban greening efforts, especially along these traffic corridors, can help act as a buffer against a lot of pollution emitted from these vehicles, as well as road dust. Additionally, we should consider restricting industrial development that brings heavy traffic and industrial air pollution into urban areas and environmental justice communities. So the Department of Transportation forecasts in 2021 forecasted that industries that rely on heavy trucks, like warehousing, for instance, are anticipated to grow over the next several years, as you can see on the graph on the right. This, of course, has consequences for further heavy truck activity and industrial activity in areas that are already experiencing cumulative environmental burden, particularly in Western and Northern Richmond. So zoning and land use policies can limit warehouse development and industrial projects that bring large trucks and other traffic to environmentally burdened communities. Over the course of the project, we saw how important it is to increase community access to data on other health damaging air pollutants that are not captured by our network. As Boris mentioned earlier, air pollution is a piece of the puzzle, and we're only measuring 4 air pollutants, PM, 2.5, NO2, ozone, and black carbon. There are many other health damaging air pollutants that are being emitted in this area, particularly by some of these stationary sources. This includes air toxics like VOCs and benzene. BACMed and Chevron have been measuring some of these air pollutants, including some emitted by stationary sources like the Chevron refinery and the landfill. These pollutants may correlate more with the health outcomes that we see within Richmond than the pollutants measured by our network. And historical data should be made publicly available in order to encourage policy to protect communities. Regular reports should be provided on the progress on the implementation of Rule 1118, which focuses on reducing health risks from facilities that have high air toxics emissions. And finally, it's crucial that communities engage and participate in the development of a community emissions reduction plan. So engaging communities directly is vital for policymakers and researchers like us to understand community concerns, for communities to identify local emissions sources and hotspots, and for policymakers to develop successful mitigation strategies. Already, local community leaders from Richmond, North Richmond, and San Pablo have been working with the Air District to develop a community emission reduction plan, or CERP. They meet about once a month. And during these meetings, they talk about things that we've been discussing in this presentation, like heavy-duty truck electrification, urban greening efforts to protect from traffic pollution, and so on. So community participation is critical to the development of the CERP to ensure a community-driven plan that reflects the community's values, needs, and concerns, and more community members are encouraged to participate in these monthly meetings to develop the CERP. Thank you all for your time. I'm going to hand it back over to Boris to thank some of our partners and stakeholders, and then we'll open it up for a Q&A.
Thank you, Karan, and thank you so much, Rebecca. Yeah, I would like to acknowledge some of our partners. APEN, UC Berkeley were critical for this project, and of course, funding from the California Air Resources Board through the Community Air Grants Program. Yeah, I think we can move on to Q&A. Thank you all.
Great, thank you. So at this point, if you have questions, please feel free to drop it into the Q&A. We have a couple that I'll start with here. So we have one question from Kevin. A couple questions from Kevin. So we had one question that talks about a black carbon monitoring study that was done in Richmond previously by groundwork. And so the question was, have you tried reaching out to local communities doing similar work? So discussing, research on this topic that's already been done in the area.
I can take that one. Yes, Kevin, we were in touch with Groundwork Richmond throughout our study and Ramble too. So we know that they visualized their data. They were collecting PM only. I don't know if they published a study, and I know that they got a grant to also do black carbon monitoring, but I've seen only the PM data. I haven't seen any of their black carbon data. So yeah, well, it will be great to reconnect with them and see where they're at and compare data sets. And then the second question was about whether the monitors will be deployed continuously. And if so, whether one can get an API from those sensors. Yes, so we're planning to...
Boris, really quickly, could you define API?
API is an interface that allows to interact with the data and use the data. Yes, the answer is we plan to collect the monitors and refurbish them, and then redeploy them again in the community for additional air monitoring. And yes, there's an API that we were visualizing data in real time and during the project, and so data could be pulled through that API. But I think the California Air Resources Board is still planning to collect all of the data to common source. I think it was called, I forget the name. But all of these air monitoring projects that was funded through CARB, all of that data collected should be hosted on the CARB's website at some point. I don't know how far they are with that effort. And I think there was a third question too.
Yeah, so there's a question about presenting to the steering committee and whether we'll be presenting this data to the steering committee.
Yeah, so we've reached out to the steering committee, and we're happy to we've told them that we're happy to provide a more detailed technical presentation, and there's been interest in that. So hopefully in the new year we'll present to the steering committee. We've been in touch with the Air District as well, so they're all aware of the report coming out, and hopefully we'll be able to give them more technical details. Either during steering committee meetings or we can present to individual working subgroups within the committee that are working on the most relevant issues that are most relevant to this work. And then another question from Kevin. How real-time is your data on the Richmond-San Pablo stationary emission source inventory? So that data is not real-time. This is annual emissions. So this is data that facilities submit to the California Air Resources Board, and we compile the data to visualize it in an interactive way so that people can play with it and see what overall reported emissions, annual emissions from different facilities are in different sectors around the area. And the interactive tool is just for stationary sources. So as I talked about it, as I mentioned, there's also mobile source emissions, etc. We haven't visualized that data in an interactive way.
Great, and then there's one question on does the steering committee or its subgroup have a public facing meetings at any time? So yeah, Boris, maybe you could speak a little bit more to the subcommittee processes.
Yes. So yes, the meetings are all public. All the steering committee is a Brown Act committee, so basically all of their proceedings are public. They meet on a monthly basis. We can share a link to the page for the steering committee, and I believe they have the next meeting in January sometime. So I encourage everyone here who is concerned about air quality in Richmond and San Pablo to join those meetings and provide input, because those meetings will decide what the emissions reduction plan is going to be for for the area. And all of these meetings are, all the people there, community leaders, et cetera, are working closely with the air district to come up with an emissions reduction plan. I think the emissions reduction plan is supposed to be finalized in the next 4 or 5 months. So participation right now is very critical.
Great, thanks, Boris. And then we have another question that says, I have a monitor on my deck. I live in Marina Bay near a business named Richmond Wholesale Meats. They have diesel trucks coming in the morning and also various times throughout the day. I realize that it's difficult to answer this, but how can they mitigate the negative effects to residents? Do you want to take that one, Boris?
Sure, or Karan, if you want to take this one.
Yeah, so I mean, again, we're talking about heavy duty truck electrification. So if those trucks were battery operated rather than running on diesel, that would cut emissions entirely. But that is not something that can be resolved tomorrow. That'll take some time to implement. In the nearer term, urban greening efforts, putting up more trees and things like that can help block or absorb some of the pollution being emitted by these diesel trucks in the area.
Great, and then maybe Rebecca, this would be a good question for you. There's a question about how much of the black carbon is thought to be from ships or other port operations.
Yes, thank you. Thank you, David, for the question. It's very good. It's something that I think definitely should be looked into, especially when considering future mitigation efforts. That would be something that was not necessarily answered in our study done here. However, local hotspots were found in industrial areas that were neighboring or closer to, I should say, marine sources of pollution. It is work that can definitely be built off of the data that we collected and has previously been done in a similar study conducted in West Oakland, where they did do source apportionment for that community, although obviously having a different arrangement of black carbon sources as well. So I don't have an exact answer for that one, but hopefully in the future it could be answered.
Thank you. So another question is interesting, and it's focused on the recommendation that data be made public. And so the question is, what length of time would air monitoring data need to be publicly available? So like for how much monitoring data would need to be made available? They say that most are currently 3 months, and there's just challenges, around actually managing and making that data public. So just the question to the researchers, how much historical data would be helpful?
I can take a crack at this one. Well, I would say that to connect to correlate this data with public health outcomes data, it's important to have data that is more long term, so a year or 2 or more, especially with the air toxics. So PM data is available, and as well as NO2 and ozone data from the air district. Again, limited data that's limited to only one location, but that data is for many years. Other regulatory network monitors are also available. But for example, there's 3 community air monitors that are currently operated by, I believe, by Chevron. There's an agreement between Chevron and the city of Richmond, and those 3 community air monitors have been collecting data for years. They collect not only PM data, but also air toxics data, which we think is critical to examine and compare with health outcomes data. And that data is collected in real time. I think it's actually visualized in real time. We can share a link, and the links are also in our report. But historic data are still not available. So that's one of our recommendations, that air toxics data that's collected, that's been collected for several years, should be. There's no reason to not be made publicly available, so that more studies can be done with that data.
Great, thank you. I'm also going to share a link in the chat that was shared by one of the participants, but making sure that everyone has access to it. So this is just a link to some of the air quality monitoring districts ongoing programs, which were mentioned earlier. So just making sure everyone has access to that. So there's a question just on the scope of electrification rerouting, whether this is, really an issue that is a state issue or a national challenge. Corinne, I don't know if you have additional thoughts on electrification and what can be done there, maybe at, the city level, state and national.
I mean, it's definitely a state and a national problem, but focusing just on the state, rerouting for sure is, in addition to electrification, rerouting is a problem that not just in Richmond-San Pablo, but throughout the state of California, and I'm sure nationally. For instance, the Port of Long Beach down in SoCal is also similar to Richmond, a very industrial area which has problems with truck activity running through already environmentally burdened communities. I think it's just a common thread that communities that are already so burdened tend to be the path of least resistance for additional industrial development and activities like that. So moving forward, yeah, this is a problem in Richmond, but it kind of reflects a broader trend in the state and likely the country as well.
Thank you. And there's a question just about commercial sources and if there were any trends that rose in that data. So I don't know, Rebecca, on if you'd like to take that, or if maybe Boris.
I can speak first to the black carbon trends, then maybe Boris can follow on. We, in the report, which I highly recommend everyone goes to see, as it's the lengthy version of the presentation that we showed today. We have the specific trends for all or commercial, industrial, and residential zones for black carbon, as well as the other pollutants that were measured, PM 2.5 and NO2 and ozone. Typically what we found were that the commercial zoned areas did have this like second highest, or on average second highest black carbon levels compared to those that were in industrial areas. Again, that these areas were neighboring homes and schools and made up mixed sources of potential pollution. Typically though, the sources for black carbon that are standard, such as diesel traffic as well as rail, were housed in industrial zones, whereas commercial zones potentially were including restaurants and those kinds of incomplete combustion sources. Boris, did you want to continue?
Yeah, it's hard to with the rest of the data with NO2 and PM, it's hard to sort of segregate different sources, commercial versus industrial. We as I said, we can look at what air pollution concentrations are near those sources, but as we talked about earlier in the presentation, it's complicated to know where emissions from certain sources actually go and where their impact is. So there are ways to do more complicated analysis with dispersion modeling and chemical transport models that takes these emission sources and known chemical transformations in the atmosphere and weather patterns, et cetera, and try to predict where the impacts are going to be. But in this study, we're reporting what actual measurements on the ground are and try to infer what that might mean, but it's difficult without more sophisticated modeling.
And then there's a question just about comparing what was found in the Richmond area to neighboring areas. And this is specifically West Oakland. There was a question, how our results compare to what has been seen in that area. I don't know if anyone can speak to that.
I'll let Rebecca answer that question because her team actually did a study in West Oakland too on black carbon.
Yeah, again, I'll come from the black carbon perspective, and I think this is a really good question, Michael. Just one thing that we struggle with, or maybe shouldn't say struggle, is we don't have access to this kind of more source specific data like black carbon is in all neighborhoods and communities in the Bay Area. So historically, West Oakland has had a black carbon monitor at their regulatory site that's kind of centrally housed in the West Oakland neighborhood, whereas the Richmond Air AQMD site does not have a historical black carbon site. So it's tough to do that comparison long term. And during our Richmond black carbon monitoring, we did do comparisons to that one site in West Oakland, and we did see that it was comparable but varied throughout the seasons and as well as during the day. Historically, from our work in my group, we did another dense monitoring network back in 2017 in West Oakland. We found that levels throughout the community varied significantly as they did in Richmond. So the variation normalized to the network average were similar. However, the absolute levels or baseline levels of black carbon experienced in the neighborhoods are slightly different, but it really depends on the sources. West Oakland having the major port right there compared to the size of the port of Richmond. However, Richmond has a large railway. So there's some comparisons that can be made there. And I think we comment briefly on that in the report as well.
Great. And then our final question, maybe for anyone who feels particularly passionate about this, of all the many air monitoring sources available in Richmond, which ones are your favorite? Do you find most useful? So there's links that they provided to, Purple Air, breezemeter.com, airnow.gov, just all the various resources that are out there, maybe some helpful direction about where to look.
That's a great question, Lizzie. Thank you. I would say, many of these resources show similar types of data. So the Richmond Air Monitoring.org website is the air monitors, the community air monitors that are hosted by Chevron that I talked about. So that data is for 3 locations, and it's in real time, and there's data on air toxics, which is very different from other sources that mostly show PM data. So that's like the transparentrichmond.org. That's, I think they visualize the data collected by Groundwork Richmond in real time. So that's PM data. Purpleware is the same. Ramble Share is also data in real time, although that's sort of a more sophisticated model also included in that data. AirNow is, of course, the go-to site. That's data from federal monitors all over the country, which can be downloaded and looked at to look at historic data. I would say all of these sources are good for Richmond. Purple airs are somewhat limited in terms of distribution around Richmond. There's more purple airs in the hills than in the flats. The clarity nodes that were deployed by Groundwork Richmond, they were more in the southern areas, I believe. So they don't cover the whole area. And again, the community air monitors that are hosted Chevron, I think that data is really valuable, especially the historic data, and I hope that's released so we can analyze it and correlate it with health outcomes data.
Wonderful. Well, that's our last question. Thank everyone for joining, and thank you all for such an engaging Q&A at the end. I will be sharing this recording out with all the attendees, and we will make sure to include closed captioning for those that requested it. We will also be updating our website and our social media with the website that Jacqueline has dropped into the chat, so you can access this recording, our slides, and the report there. And we'll be sharing it out on our various social media channels as well. But thank you so much to our panelists, and thanks to everyone for joining.